Okay. So Alice just wrote and said she's going to be communicating by text because she's on VPN. So apparently there's no camera or sound. And as things get worse, some of the yeah, I get it. And so that's we look forward to hearing your comments.
Okay.
Okay. So you're going to see me checking the chat a lot more often than I would normally do when I've got backup peeps. But Greg, I'm going to also
Mhm.
lean on you a little bit for some of
Yep.
that help.
Oh yeah, I'll be ready.
Okay. Thanks a lot.
Mhm.
Okay, I asked Greg to step in at the last minute, so he's being really kind. He's got a lot going on. He's wrapping up a few projects. Okay. So let's talk about machine learning and if you this is your first time visiting a water cooler chat, it really is a chat. We really want, and by the way, yes, I did cut my finger. We really do want um, to have a conversation as much as we can have in this setting. So you can unmute and make a comment. You can also stay off camera if you're enjoying your lunch. I don't blame you at all. Or you can just stay off camera so that, you don't um, have me going, what are you doing over there? Because that's not, you grade us, we don't grade you. So please do pop up with questions, comments, to each other, to us. It's all good. Okay. But I'm going to tell you, I'm going to explain machine learning. So the first piece is that machine learning is actually a learning process. The machine, which is a computer program, actually figures out information and learns from it and then builds on that over time. And so it is called machine learning, not just to be fancy. It's what it really does, right? So samples here is that it can figure out your major gifts portfolio without you telling it what to look at. You just throw a bunch of data at it and you go, what's the best major gifts portfolio for us to have in Wichita? And it will suss out, according to the data that you feed it, what it thinks of as Wichita. It still uses a target, right? So that means that some machine learning is called supervised, which means you tell it what to go figure out. And some of it is unsupervised, which is cluster analysis. What do you see in here that groups together? Okay. It still builds out a model because it comes back with a characteristic. So it's essentially, if you think of the machine as this cute little robot that runs about the big warehouse of your data and comes back with a shopping cart of the best characteristics that make up a good gift prospect, but from our sample, then that's how it works. Okay, we have in the early 2000s when we all started doing this, we were using linear models. A linear model says, Marianne is more likely to give every year that she gets older. Marianne is more likely to give every step on the capacity ratings ladder she goes up. Marianne is less likely to give every year she has been in retirement, right? That's a linear model. The minute you add on or take on, so linear models work on the cost or profit of one more. That's a regression or taking a derivative is. Okay.
Mhm.
So for linear models, you actually have a lot more supervision of them. You tell it what to look at, you test what to look at, and then you tell it how to look at it. You do a lot more data preparation. Um, and that's why it was up until 2015 or so, we were making big bucks just doing major gifts models, those of us who did them, because it was easy to build a linear model, get the lowest hanging fruit. The problem is the middle of the tree where the fruit is the sweetest and the deer can't get it. Think of the deer as your annual fund. Then we were not getting our best prospects. We were leaving people out, right? BIPOC prospects, the millionaires next door, the inheritors, the engineers who were introverted, right? We were not getting those pockets, right? We were just
Mhm.
getting the main line. And that doesn't work anymore now that wealth is significantly concentrated because because we're just going to have to just get more widely distributed about how we raise money in order to get at the 99% of the people that don't own half the money in the world. Does that make sense?
Mhm.
Thanks, Greg.
Yeah.
Okay.
I was going to say sometimes this is kind of a self-fulfilling prophecy that often the linear models told us, hey, the more times you contact the donor, the more likely you are to get a
Hmm.
gift. And the thing was that you had preconceived notions about who you were going to contact. And therefore, it was telling you, well, the more you ask, the more you get, which you probably could have known already.
Right. And that so that came up with like 18 times a year you ask somebody for a gift. How about now? How about now? How about now? How about now? And
Hmm.
eventually the your envelope just starts getting recycled before they even look at it, right? I disagree with the gentleman who insisted that we do 18 times a year. I forget his name and I forget the name of his book. Okay. So this is what a decision tree looks like in the to a data scientist. All right. So this is basketball data. This is how I was practicing for the online course that I'm going to try to advertise to you at the end of this presentation. So if the home team has uh, a half or fewer steals less than the away team, if they do this, yes, then they're actually more likely to be the home team is more likely to win. So if they don't have to steal, they're more likely to win. Well, that makes sense. And you're like, duh. But the machine went out and said, okay, I got steals, I got bases, I got fly balls, and I got all kinds of plays, right? So which of those matters, right? So when we figure out which ones matter, we just go duh, but then we also use it, right? And so it goes down to this is the average final score. So it's less than 2 points, which is why um, I see your question, Ruben. This explains why betting services do 1.5 points when they do a point spread because it's usually within 2 points or two. What is it called? Runs.
Hmm.
I love it when I
Well,
try
for
to talk.
baseball, it's runs. For
Thank you. Yeah.
basketball, which is its points. Yeah.
I crack you up a lot, Greg, when I talk about sports. It's like the picky guy on the football team.
Just because I was thinking about taking a PhD in sports history. I mean,
And you did, didn't you?
no, it was church history.
Oh, wow. That's an interesting turn.
Yeah, well, I mean, one of those two. So,
Okay. And so if they have more steals than the away team has, then these other characters could come into place. But notice the steals takes over everywhere, right? Okay.
mhm.
Let's look at something less a little less intimidating. So Ruben, the question is how does this differ from the stuff that Blackbaud does? Now, the old days, Blackbaud did the linear stuff. Okay. And I don't know if Blackboard Analytics does machine learning or not. You can ask them. You can ask them, do they include artificial intelligence and machine learning in their analytics work? We do. I know Ben Swaley Flestner does because Joshua and I Burkles discovered it at the same time. But I would ask him. But the Blackboard from the 2010, when you paid him $10,000 for a major gift model, it was linear regression, which is the every year Marianne gets older or Greg's example, every time you visit Marianne, you're more likely to get a major gift from her. And it just like you can only have one line going up. There's also no place where you're what is it called? Law of diminishing returns, right? Where your return is going
Right.
cranking down. Would
Yeah,
um
they were doing, I believe, mainly binary, so that it was more than 5 visits or less than 5 visits. And you're right, there was no indication, well, okay, if 5 visits is good, then 10 visits is better. Not necessarily.
right.
So,
Yeah. Yeah, you have to torque data in a lot of more ways than linear regression.
mhm.
Okay, but when we speak English to you guys and to your major gifts team, we do things like this is your giving group that we figured out. These are the characteristics that matter to them. And notice that there's a progressive set of characteristics. So this $1,100 or more, this is from 20 something years ago. This is a sample from 20 something years ago, right? So leadership annual giving, see, they cultivate it by phone more than twice. If you really like the conversation, you'll do it 6 or 7 times, but that's okay. Just get them up to twice as long as they belong to a committee, right? Once you get to major gifts, notice that the differences here is that you see them in person rather than by the phone. And then the other difference is they actually have an asset because major gifts is a gifts of assets, right? And then principal gifts is they're old enough that they're willing to think about what to do with their money. Make sense?
Mhm. Mhm.
Okay. Whoops. I'm looking at you guys instead of, there we go. Okay. So when we take a look at this, whoops, something happened to my slide. I am so sorry. This is a slide that I should have thrown out. I apologize. Okay. But because we talked about neural networks, of course, I have to show you what it looks like to the data scientist. A neural network, it takes all this stuff and it actually does a process called perceptrons. Not that I clearly understand that. I just know that I've used it from time to time. I don't have to know how the airplane flies. I just have to know how much it costs to get on and where my seat is, right? So neural networks is similar to that. Notice that it says I got neurons. And so this employment flag goes in and it says I went into 4 or 5 different neurons to inform whether or not they're going to make a major gift this year. It starts with a natural bias, which in linear regression we would think of as the starting point. And the most important thing to take away from this illustration is this isn't something we can put into a query statement in our database. We don't know how these neurons are built, and it won't tell us. That's a neural network is what they call a black box algorithm. Unlike here, we can just put these things in and then say best segment equals donor, best segment equals major gifts, right? Here, um, all we get is here are the prospects who would more likely make a major gift this year than all the others. And then here's the list of people. It just says
Mhm.
these people are likely. So it's black boxy, which is annoying when people say to you, tell me exactly how you arrived at this, right? Okay. Questions or comments? I'm going to keep encouraging. Okay. The other piece, this is using probability, but it's also using machine learning to get at this question. So the other piece to think about it is, let's say that of your entire constituency, 2.5% give at $100,000, give a major gift level. Those $100,000 donors, by the way, may be split between major gifts and leadership annual giving because some people are annual giving donors, whether you like it or not. And you're just not going to get that 5-year gift of assets that major gifts requires. Okay. But once you go and pull out all the people whose average giving per year is $307, and that's per year over the last 5 years, or the definition of however you defined it, you go up to 27%. Now you've gone 10 times more likely to give. And think about those of you, let me know what is the highest number. Oh, thanks, Alice. Let me know the highest number of prospects each of your gift officers has in a portfolio. Do any of you have more than 150 prospects in your gift officer portfolios? Liza is a no. Okay. Because once you get up to there, you've got to help those gift officers figure out their stuff. You've got to help them sort out their prospect. Ruben has about 100. That's perfect, Ruben. We're starting to
Mhm.
talk about
Mm.
150. Yeah, we're starting to talk about, Tanya, God love you. 125 is the max. Now, how do you, of the 5,000 million major gifts rated prospects that you have in your system, who are the best ones, right? And so this is what machine learning does, is it says not who's capable. That's the prospect research team. Here's capacity. By the way, prospect research also informs inclination and affinity, but likelihood to give, that's going to come from doing a machine learning task. So once we tell the gift officers, you have permission. Yeah, Alice says Ruthie cut the team here down to 75. That's Ruthie's. That's the hill that Ruthie stands on, and
Mhm.
Wait,
I
which
stand
Ruthie
behind
is
it.
that?
Ruthie Giles
I
is
gotta love her.
our prospect management expert. Yep,
Mhm.
she's not with us today. She lost her mom this week, so
Mhm.
she's dealing with that. Um, but if we said to gift officers, look, you don't have to talk to them unless their average giving is $307 per year. Gift officers love to hear that. That $1,100. The gift officers that I worked with, they love to hear that because they didn't want to talk to prospects who have never given. You don't even know why they've never given, right? And then this one, this weird characteristic, 2 or more relations of record. Well, for this client, it meant they had like a friend in their relationship record, they had a business associate, and they had family. So it doesn't matter what the relations were, okay? But we went up to 1 out of 2. So instead of 3 prospects for every $100,000 gift, now you got 2. And now, when when Scott and Alice and Tanya are trying to get down, and Ruben are trying to get down to a reasonable number of prospects for the gift officers, they can use these slicing characteristics, and then they can work on building the relationships with the rest of the major gifts capable of prospects to see how to work it. So how do we do that, right? What is the set of behavior characteristics that push me toward being ready to make a major gift, right? This is the Dunlop model, David Dunlop from back in the 90s. Okay. So one of the things that we say is we actually say, look, this is this is your behavior pathway, right? So how to get Marianne to buy $100 worth of stuff on Amazon? Well, you send her a note that says, your favorite blah, blah, blah is on sale for $10.99. And I go on and I go, okay. Oh, and while you're here, you want this, you want that, you want this. It's right end capping in a store. Well, how do you walk a prospect toward a major gift? The first thing we can know is right out of the gate, corporations, foundations, widows, estates, and organizations. That all makes perfect sense. My husband died. I have an obligation to make this gift to his alma mater. There you go, right? But in years 1 through 5 of their relationship with you, so if you do their data entry date or the record add date, these corporations, after 5 years, all these organizations stop giving. All right. Widows and widowers, sorry, not widowers, widows and widowers will settle the estate and then disappear on you. Now, is there something you can do about that? I don't know, right? You have got to talk to them and ask them. Okay. But everybody else, in years 1 through 5, the prospect makes a first gift of $25,000 or more when you cultivate with 2 or more touches. And it didn't matter for this client, it didn't matter whether it was phone, email, or in person. Isn't that cool? What if you're able to do that? You're able to describe the cultivation chain that gets here. Now you're taking some power away from your gift officers, right? You're taking some authority, you're taking some of the art part out of them, out of their pockets, right? And you're also empowering them. So it's up to your team to decide which they want to do. Greg,
Mhm.
have you ever advised gift officers to do something different?
I've also tried herding cats. Um,
Oh yeah,
Not that
we've
I'm
seen you try
picking
to
on
hurt
gift
that.
officers, but I've rarely met a gift officer who would say, um, we need to talk to prospects fewer times. Although there are some prospects who get, relationships with development officers and they see each other every week for lunch.
Mhm.
So you have to kind of find a happy medium with that. And I think the biggest thing when I worked at, when I was working at, on site at universities was trying to explain why this was successful. Here are, and not just showing if we have between 2 and 6 touches, we're more likely to get a gift. To be able to say, okay, here are 10 examples of this working. Sometimes you kind of have to draw back to that. It's kind of like if you're watching, if you showed the basketball example, say you're trying to explain why the 3-point line is, important in today's NBA. And it's hard to do that. But then if you show Steph Curry, making 3-pointers from everywhere and then showing him holding up the NBA Finals trophy, that's a lot more powerful than just saying, this dry statistic. Well, teams that shoot 3.7 3-pointers per quarter are more likely to win.
I agree with that, Gregory.
Mm.
My gift officers constantly want to say, well, can you show me an example of how what you're saying worked?
Mhm.
Who got a gift out of doing what you did?
Mm. Mhm.
So
You
it
say,
puts
do
the
you want to be
pressure
the hero?
on. Sorry, Marianne?
Oh, sorry, do you say, do you want to be the hero?
We're lucky to have a couple of gift officers that really listen to our recommendations, and we constantly point back to their success stories.
Yeah, great.
But
Mhm.
out of 26, 1 or 2 really listens and takes it to heart,
Yeah,
so
that's about right. Yep. 10% top of the
Mhm.
class. I've had a few situations where the gift officers would come to me and say, Michael's raising all this money. Why are you giving him great prospects? And my answer was, Michael is a leadership annual giving officer. He raises money because he doesn't get off the phone. We don't give him prospects. We give you prospects, right? So that was one. But the other is one of the gift officers I've worked with was an Olympic athlete before he came to Cornell. Amazing man. He had to stay overnight with a prospect in a snowstorm because they were up on a mountain on the west someplace, and but he was not afraid to go out there and ask. And you're right, and that's what tells people that it can be done, Lucy. You need those early adopters. Ruthie talks about that in her book that we're working on right now. So thank you. Okay, let me make sure I'm on the right slide. Okay. So when you talk to your gift officers, what you can say is, listen, you can actually the capacities actually matter. The capacities that we do actually matter. And the ask that you guys are doing, when you ask above rating, that means that informs us, the research team. When you ask at the rating, everybody's happy. But when you ask below the rating, help us understand why, right? And once you put these, you have three categories. And you can ask machine learning, what are the contact reports? You could even have natural language processing. What do they call that now, Greg? Big, large language models?
Yeah, large LLMs, large language models.
Right. It used to be a master's degree in law, but okay. Every 2 months, you got to rename things so you can feel more special because you know it, right? But
Mhm.
the large language modeling is machine learning. It's also artificial intelligence, understanding what coming out of Marianne's mouth so we can respond to her as a machine, right? But if you took those three categories and said, what are the characteristics that put somebody in the category of ask below rating? The answer could be the gift officer's training level, or the answer really could be that the prospect doesn't have a high enough inclination, which could be described as, there's no philanthropic gifts identified through screening, or the prospect isn't on committees, or so we can start saying there are some mitigating factors. When research does these things, we note that normally prospects who have never been volunteered for anything tend to give below their rating. But we're sticking with this rating because this is what they're capable of. It helps the gift officer set the stage. It isn't all about telling on them. Okay? So let's talk about this use case. How many visits, right? So when we look at this was live client data from some time ago now. So Greg taught me how to do Monte Carlo simulations. And when we talk about probability, we actually go for this kind of thing. There's two ways to say what is the optimal way. One is Monte Carlo. The other is an optimization technique that I learned how to do this year. And it was a lot of fun. But anyway, once you get past 3 visits, you don't have to do any more. So that doesn't mean that gift officers can't do more than 3 visits, but it comes back to the metaphor that Greg was sharing with us. If every single visit counts as something amazing, and I'm not counted on how much money I've got in it, I'm counted on how many visits I make. I'm gonna go visit with the grandma who feeds me cookies and tells me stories every week. And not get to new prospects that I don't know, and I don't know if they're gonna yell at me, and I don't know how it's gonna feel, and
Mhm.
excuse me, is their dog gonna bite me? That kind of thing.
Mhm.
But the piece is that this red line is the likelihood, right? The percentage of the households who made a major gift, that's red. The percentage of the households who did not. So once we get to 3 visits, we're kind of done.
Mhm.
That's when the efficient horizon comes down, if that makes sense.
Yeah, I'd kind of add to that. I mean, think back with your organization to the biggest gift you ever got, and think of how many times you actually visited that person. In many cases, it's going to be only one, two, or three. Especially when you think to yourself, okay, if we're asking a billionaire for money, how many times is that billionaire actually going to meet with us? Probably not that many times.
Right.
So, I'm thinking to myself of a gift I was involved in some years ago. I think we met him 2 or 3 times, and he gave us $20 million. He had no previous connection to the institution, but he was a very busy man. I mean, I sometimes would see his private helicopter fly away from the organization.
That's great.
So, you know, he's a busy guy. We were lucky to see him two or three times.
Right. Yeah, and the other piece of that is for this client that whose slide we're looking at, the one of the questions was there's a new dean for the school who came in and said, do I really have to visit prospects as often as the other dean did? And when I said, you know what, it only takes one dean's visit to solicit a $1 million gift, she was like, yeah. So that machine learning helped there too. Okay. Oh, and I think this is where this actually I was referring to that on this slide, right? So when to bring in a key solicitor is the other piece. If your volunteers are starting to get some exhaustion, then you can be strategic about when you bring them in. Also, everybody wants to win. I mean, when I'm at work is when I'm losing. I have to do trivia, administrivia. Sometimes people are mad at me. Sometimes it's Greg. You know what I mean? But if I'm doing volunteer work, I want it to be satisfying. Even if it's hard, I want it to be satisfying. And so we don't want to bring in a key volunteer for a lost cause. That's not a last ditch resort effort, right? Key volunteers don't come in to stuff envelopes unless that's what they want to do and they're hanging out with people they like. You know what I mean? And there's cookies, right? Key volunteers want to feel successful when they walk away from whatever they volunteered for. Okay. So this is down here. One visit by the key volunteer lifts the probability to give $1 million to 85%. That was the finding that we found. It just took one, and the new dean was very, very happy. Okay, but volunteer visit lifts a prospect's gift by this much on average. This is the stuff that says, we're gonna. These are the things that you can do to think about how you want to allocate your key volunteers. The small college that I worked for in the 90s, they had a $5 million fundraising campaign, and that was a big deal back then. After I left, their campaigns were much larger, 5 million a year. And so the president was visiting with me for $1,000 gifts. Where is my cursor? Okay. Okay. The other piece is that machine learning informs keeping prospects at annual giving versus major gifts. Annual giving's job, it has two jobs. One is to bring in unrestricted revenue, unrestricted gifts, right? But the other job is to cultivate prospects up the giving ladder. The problem is sometimes my ladder is short and I'm going to stand on the top rung and I'm going to stay right there. And so I'm not going to give a planned gift or a major gift. I'm going to be self-determining about where I want to give every year. So being able to, machine learning allows us, instead of that linear piece, right, that says this is how much you could ask Marianne for. It says, by the way, when Marianne looks like this, she's actually more of an annual fund prospect than when she looks like that. Questions or comments? Is this fun or what? Okay. Okay. So the final piece, of course, and then when we were starting to study Power BI, we of course wanted to build dashboards like crazy. But the other piece is the prospect scorecard. I got this idea from reading a marketing book 4 or 5 years ago now, where he said you want a marketing scorecard for each person. And I was when I was working at Cornell, I worked with a smart man, Kevin Coates, who talked about using the baseball scorecard as an emulator for the prospect scorecard. Think about it. This is the segment this prospect is in. This is the capacity rating the research team has contributed to. And this is what the machine learning said was the likelihood for each of these, the highest gift estimate based on linear regression or machine learning, the last gift amount, and then recommended, there should be a recommended segment in here as well. And then when was the last gift? I mean, thanks, Alice, your team is going to ask for a lot more, right? I need a whole lot more on this. And the answer is, okay, but how much real estate do you want to give up, or how small do you want the print to be? But really, when it comes down to it, you're going to think about if you had a prospect scorecard that pretty much laid out right in front of you for every prospect, this prospect really ought to be an annual giving or an engagement, right? The prospect's a non-donor, automatically they go in engagement. And when we did this by hand, Ruthie and I did this by hand for a client, not only did we say, excuse me, not only did we say recommended segment, but we also said recommended solicitor. So this is a trustee, the recommended solicitor is the vice president. This trustee is the recommended solicitor is the college president, right? And it worked really well. Hey, Sarah, I didn't see you there. I can't find the cursor. Okay. So there are some drawbacks. Okay. Machine learning does need to continually learn. One of the things that I kept saying is that you can throw all kinds of data in there and get an answer. The thing is, if you throw in that Marianne gave $100,000 and Marianne is 64 or older, and Marianne's life giving is greater than $1,100, it's going to say Marianne's very likely to be a major gift prospect because Marianne's already a major gift donor, right? So you still have a problem with collinearity, you still have a problem with confounding, and you still have a problem with endogeneity, right? Like this is the same as that, right? It's raining, I need to wash my car, therefore, or no, what, how does it go? I need to wash my car. It's Saturday, therefore it's raining. That's confounding, right?
Mhm.
So you do need the machine to keep updating. Even if once you build your query statements and enjoy them for a while, you're still gonna let the machine keep learning. The other piece is that neural networks are black boxes, and in fundraising, when their reputation matters to them, fundraisers do not want to take black box answers. They just don't want to deal with that. You know what I mean? And a random forest, which is one of our favorite forms of machine learning, the purpose of a random forest is to make a lot of decision trees. A decision tree is here's all the prospects. This large branch are prospects who have never given, and on the branch there are prospects who look like prospects who are given and prospects who haven't. These are prospects who've given 1,100 or more, and on this branch, and then blah 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 blah. Now think about it, you take this entire pool and the machine says, you know what? They're not all live in one tree. There's actually this other tree over here of non-donors, and this third tree over here of athletics, and this fourth tree over here of people who buy theater tickets. It's not the same thing. Now you have a forest, and that's what decision tree is. But the thing is, a random forest, a decision tree based model, especially one that's as sophisticated as a random forest, which will come up with 180 rules. Once you get down to the leaf size, you're looking at two people, right? And when I make the mistake of leaving like the prospect ID in the model or the prospect's, sometimes the prospect's last name, it will say, you know what, the Gates family, they're multi-million dollar prospects. And I'm like, oh gosh. And I've got to pull it out and rerun it because I pretty much just made a mess. I pretty much just
Mhm.
said donors are donors, and that's tiresome for anybody to deal with. Okay. How do I get started in machine learning? This is the commercial portion of the agenda. Thank you for staying with us this far. The first one is you can start doing some basic learning, basic analysis just in your Microsoft Excel. And Greg does have courses on our Teachable page. If you go to stoppel.com and look up courses, you'll see our catalog. Or the new course that I just put out, which is why I wanted to talk about machine learning, is on machine learning in R. So if you've taken our R analytics course, would be your next course. Or explore some of the idea through your dashboard. And of course, we're happy to sell you our services because that's what we're here for. Okay.
Mhm.
So the machine learning course, here's the obnoxious long link, but there's actually a better one on our course page, on our course catalog page on our website. But you do need to build a linear regression model in R in order to follow through with machine learning in R and Weka. I am, by the way, right now building a beginning course in Python because people have asked for that. But we do have a Power BI course. Our next water cooler chat is May 13th. We're going to talk about probability. So we're going to turn into Nate Silver. Nate Silver wrote himself a baseball simulator using probability, just probability. What is the probability that Derek Jeter is going to get to the next base? And he did it with what we call naive Bayes. He did it with probability analysis. So we're going to talk about how you can use probability as a simplified version of machine learning instead of learning how to code R and do the
Mhm.
whole business. We're going to show you how to do some of this.
Andy did about 80% of it in Excel. So,
Did he?
so,
You couldn't wait to say
so,
that.
so you don't need really, really complex tools to be able to do a lot of this stuff. Um,
That's the long-standing academic debate between Greg and me. I'm like, Excel can't do everything, and Greg's like, watch me.
I'm going to get the Excel flag one of these days, so I can carry it into, into any meetings or have it hanging behind me when I do a presentation. By the way, if any of you are going to be at the Case Drive, thank you, Alice. If any of you are going to be at Case Drive down in New Orleans this year, I'll actually be doing a presentation on probability as well, although it'll be a little different from this one. Um, so yeah, yeah. And as Marianne said, we have a Power BI course as well where we do talk about some of these techniques.
So now we have 20 minutes left. We can talk about anything you want. Do you all agree with Greg that Microsoft Excel can do just as much as a statistics package can do?
Well, I'm not going to go that far.
Okay.
I'm not going to go that far
You're not going to wave that
because
flag all the way?
I always say that Excel can do everything. It just does some things very, very, very slowly.
Mm-hmm.
Um, but what I did want to say is that one of the things I've learned in working with development officers and just everybody in an office is when you come to them with ideas like this, you've done your machine learning, you've put things through neural networks, you've come up with these concepts. The last thing you want to do is to go to the rest of the people on your staff and say everything you thought you knew about fundraising is wrong. You sometimes see those clickbait articles that say everything you knew about cooking bacon is wrong, and the first thing you think is, I know how to cook bacon. What do these people think they are? Um, what I always tried to do when I introduce things like this was have at least one example, preferably two examples for these are the things that we're doing right that have been proven by whatever technique we've used, whether it just be simple binary regression or machine learning or something like even like Microsoft Solver, which is another feature of Microsoft Excel. So then you introduce the things like, okay, here's how we can take that and improve on what we're already doing. Um, you know, I think the toughest thing to do in fundraising is to get, oh, thank you, Sarah, to get people to kind of reconsider conceived wisdom. And in fact, this is something, I've been putting together my probability lecture for Case Drive, and one of the examples I'm going to use is how um, we always felt at one of the institutions I worked at that a certain graduates of a certain college were unlikely to give. They were bad donors, and everyone came up with reasons why they were bad donors. These donors don't like us. They don't have a lot of money. They come up with all these reasons. And when I got our screening back, I thought, yeah, they're actually some pretty wealthy prospects in this. Why are people saying that this college is not likely to give? And what I ended up finding out was that although in um in in the database it didn't look like these were big donors. The problem was that most of the graduates of this college were women. And when I got there, this was a very kind of, I'm not going to pick on this college, patriarchal type college that their hard credit was always to the husband. So when you ran a list of donors, the a lot of these female graduates had married male graduates of the college, which happens at a lot of universities, especially for older alumni. So the husband was getting the credit for the gift, even if it was the wife who had decided to make the gift. And when I started doing, adding soft credits instead, and then I started saying to myself, well, you know, a lot of these graduates, there are extenuating factors as to why they were donors. And when you put them, now back then we didn't have neural networks, but we did have at least binary regression. So what I did essentially was I did a Mythbusters challenge after that. I talked about, okay, we think these are bad donors, and surprise, when we take out these extenuating factors, these are actually among our best donors. And when you start looking at the fact that, as a couple, they're giving large amounts of money, we were always discounting, the wife's or the female partner's role in this gift. We actually start need, and that really did change a lot of minds, fortunately. We did start, you know, looking at the graduates of this college as a potential, um, source of giving, as, potential good prospects. That did change a lot of things for our campaign. So I think that, you know, we we are in the business of myth busting, I think, and we have to kind of step forward with that. But we have to salve it with these are things we're doing right.
I agree. Actually, I tell this story a lot when I was at Lesley, what is now Lesley University. I cited a lot of prospects who were married to Harvard law grads. And then one day I was walking out to lunch and it occurred to me the dorm for Lesley and the dorm for Harvard Law were across the street from each other. So, there they were in the 60s, and so
Yeah, the institution I was working for was kind of isolated. It wasn't like out in the middle of nowhere, but it was hard to walk anywhere from where they were. It's not like you could just walk downtown, because of where they were situated. You couldn't really go unless you had a car. And back in the old days, most students didn't have cars, so the only people they were also on campus. And so that's why there were a lot of married alumni.
oh yeah, the happiness factor.
Hmm.
Yep.
Hmm.
I graduated from here and I met my spouse here and I'm really happy. So, yep.
Hmm.
Also, there's no competition with your spouse's alma mater.
That's true.
Yeah,
Yeah.
double winners. What do you all think? You want to try any of this? Everybody is so introverted.
It's definitely interesting. Some of the things you were talking about in the beginning were new to me. So I didn't quite understand exactly how they got their models. I just know that they blackballed target analytics did them, pushed them in. And like you said, it was kind of like that black box, like just
Right.
take these numbers and run with them.
It
So
felt like that. Yeah.
yeah, it's
Mhm.
good to see that because when we're taking those numbers as prospect, portfolio managers or whatever, and pushing those stats to the fundraisers, they want to know, well, why are you saying they have affinity? And why are you, where did you get that? I know they have a lot more money than is showing up there. And what does that mean? And so
Mhm.
you almost have to arm yourself with that data before the meeting so that they still trust you and still have confidence in your responses.
Right.
Mhm.
Yeah. You're going to ask me to do something. You'd better be able to show me that it's going to lead me to something. Right.
Yeah.
And your comment harkens back to your early comment, Lucy, where you were talking about, I need to show an example of success. So if you take some of those key characteristics that Blockbot noted, and you can ask your Blockbot representative to say, can you give me the top 3 characteristics that went into this model so I can help my gift officers adopt it, right? And then you'll take those 3 character and you'll pull out the prospects that are new prospects. And they'll be like, oh, why didn't we notice this person before? There you go. That's what the modeling did. So
That's a
it's the
good
same
idea.
thing. Yep. We do that for clients now. It's like, you blah, blah, blah at us all you want about this fancy thing that you did. And I get a little too carried away talking about the fun of the work, right? But then when I say, here are 2 new prospects that we saw that we think would be interesting to you, then everybody's on their laptops looking that person up in the system. And that's when you have the
Right.
interest. Yep.
Yeah, and I think also that the complexity of a model obviously the more complex a model, that doesn't necessarily mean it's better.
Hmm.
But if a model is so simple that you can reverse engineer it yourself, then it's you probably need to look at
Right.
why the model was built that way.
Right.
Many years ago, I worked for an institution. We sent out a screening, and I put myself in the model. This is also a very good thing to do with any model. Put your own data or make up data. Sometimes I put in data with my cat's name or something to just see what the model would claim that my capacity was or my probability of giving was.
Yep.
And I remember one model coming back and it claimed I was a major gift prospect. And
It's
I
owned a
I
nice
was
house.
not at the time. I was not at all.
Yeah.
And so I was like, okay, how did they come up with that? And I did some analysis and found out that one of the things they were doing was if they could find you owned real estate, they added that to the model. So, okay, someone has a $200,000 house. We're going to take X% of that and add it to the model. But if they couldn't find any real estate, they just mark you down for zero.
Oh,
So, if you were living somewhere and you were lucky enough to have a $100,000 house that you could afford, you had a higher rating than someone who had millions and millions of dollars of real estate that they couldn't identify.
okay. And you're in a co-op in New York. Yeah.
Or, oh yeah, or some places will sometimes say you're living at, I don't know, an apartment block like the one I'm living at now. They would take the entire value of the apartment block as your
Cool.
real estate holdings. And all of a sudden, boom, you're $1 million prospect.
Too
Yeah.
bad banks don't think that way.
When we
Mhm.
present the data out to our fundraisers, like this is what came back from donor search or highwave, or we are always really careful to say, like, this is directional to
Hmm.
help you. This is not like exactly. And since we've kind of switched to that almost rebranding of presenting the numbers, they seem to have more confidence in it.
Right. Because you're not saying
Mhm.
you have to swallow this bite of elephant the way I feed it to you.
Mhm.
Right.
Yeah.
I have a quick question,
Okay.
similarly related, about how to calculate affinity. We just had a screening done of our database that pulled affinity, and I think they said, if if the donor had ever given to our organization before, they had high affinity. And I was just wondering, is there another way other than giving? How do you find affinity other than, yeah, they've given to us before? Because maybe the gift was in 1985, you
Hmm.
know?
Yeah. One of
Mhm.
the books I read when the internet was brand new was crap, The Race to Relevance. And I'm looking at my bookcase. The Race to Relevance talked about how we no longer have control over our content, but you know what? We also are finding out who our fans are. And so think about the ways that you express affinity to your favorite organizations, whether or not they're for nonprofit, right? So you declare it on your LinkedIn page, you connected to it on Facebook, you send them emails, you fill out surveys, you attend their events virtually or in person, you serve on their committees. Those are all affinities. My alma mater knows how invested I am in them because they hear from me all the time. They had a data science weekend. I said, I want to come next year. They also know what my capacity is because I tell them, you know. And so the affinity is, it's how do I feel about you and are you important enough to me that I would give you money, right? And so that, that's your next question. Like even event attendance, one of the things I used to talk about with measuring event attendance is how do you figure out the I want free chicken versus the I'm here to hear more about my organization. And it's really about which events they attend.
Mhm.
Sometimes it's about whether they bring extra people with them. So
Mm.
there's lots of opportunities to measure all that if you can connect them. So that's the problem with the social media piece. And that's why we did a sentiment analysis course. How do we figure out the social media piece and what are the things that attract more people and get more engagement? And then you have to ask them, can we find out who you are? You know? Except
Mhm.
if it's your page on Facebook, you get to find out who they are, I think, still. But Facebook has been more and more circumspect. But one of the things the book, The Race to Relevance, talked about way back in 2007 or 8 was if somebody, is related to and just ask them to put a badge on their LinkedIn, give them electronic badges. So we use Badger, Badger, for some of our
Oh,
Stop Health stuff, right? Just ask them to take your badge, and now you've got a tag on them. It's the same as giving them a cookie on their page, right? So then you find out who your fans are.
so electronic badges on LinkedIn, you say?
Yeah, or on their Facebook page. Can you put this badge on your, you're one of our greatest fans. We'd love it if you wore our badge, just like the logo hat and the logo t-shirt and the logo whatever.
Mm-hmm.
The bumper sticker on the back of my car, it's the same thing. I'm a blah 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 fan. Great.
Great,
Yeah,
thank you.
I kind of wanted to respond to something Sarah said in the chat because I think it's very interesting. She says, I'm fascinated by the potential, but I'm always a bit unsure of AI solutions because there's a tendency on the leadership side to assume that these can replace the human factor in our work, which current experience shows us not the case. Yeah, I mean that's
Yeah.
as someone who spent 7 years researching one topic and still didn't feel like I completely understood it. Um, I'm very wary of AI solutions to just about anything. I mean, a while back, I was driving through Colorado and I wondered to myself, I wonder what the lowest point in Colorado is. I know the highest point is Pikes Peak. I wonder what the lowest point is. So I type it in Google, and now you have that Google Copilot that comes up that gives you this AI answer, and it said the lowest point in Colorado is 3,407 feet below sea level. I don't think that's right.
It's
And
like an airplane below sea. Like,
yeah, that's probably the deepest mine in Colorado, but
well, maybe that's it.
what I fear with AI most of all is that the solutions it gives often are so hallucinated because it pulls bad data and then another AI comes and finds that data and
Yeah.
it
And
repeats it and then you
perpetuates it.
just get this long string of hallucinations and it erodes confidence in the system. What I particularly fear is that AI does not change to circumstances. Your institution will always be changing to circumstances that um, one year it may be important to raise money for this project, and next year it's important for another project. If AI is always giving you the same solution over and over again, it's not actually learning. It's just pulling the same data over and over again. The other problem is the old garbage in, garbage out problem.
Mhm.
Um, if I have data, and this is something that's very close to me because I'm doing a lot of data cleanup right now for institutions. If I have data that's not very consistent, not very clean, and I throw it into any system without any consideration of what kind of state the data is in, we're going to get a bad result. And
Mhm.
AI doesn't know if that data is clean or not. It doesn't know if it doesn't know, for example, that so and so state college is now so and so state university or things like that. It doesn't know that we used to call we now call the College of Engineering the College of Material Science or something like that. Um, so there's so many reasons I think that AI is I always say AI is not ready for prime time. My brother-in-law has a Tesla and he's always telling me like, oh, look at the self-driver on this car. And I'm like, okay, you can do that when you're by yourself, but don't do it when
I'm
I'm
not
in the
going with you.
car. I'm not ready for that, you know. So, and I think that's what we say to the leadership, you know. You can't trust AI to tell you what the lowest point in Colorado is. Would you trust it to drive your car to work with when you're blindfolded?
Mhm.
And that's kind of the same thing you've got in your office. If you're quote unquote blindfolded by not knowing what your data is saying, would you trust AI to drive your institution to the campaign goal? I wouldn't, you know.
Mhm. Yeah, I have to agree. Oops, I'm trying to get
Mhm.
back to an interesting slide. I have to
Mhm.
agree. The in the 70s they invented microfilm and then they said microfilm's going to replace books. Who would read a book with microfilm, right? Even with a Kindle, it's hard to get me to read a book with Kindle, especially if I have to hold it up, right?
Mhm.
But the other piece is that we've had this competition all this time um, where it's always feeling like, what do we have to do to get rid of the air quote administrative staff in the fundraising office so we can have all gift officers all the time? And so prospect research comes into threat every time a new technology comes into play. So screening showed up, and then prospect research was under threat. And then they figured out that, like Lucy was saying, that if you screen me, it's going to say I'm into RV camping. I'm into camping, not RV camping. It'll say that I'm attached to a certain foundation. It will say that I was an Olympic ice skater, right? It still takes a human to interpret it. And if you have the gift officer losing her time interpreting screening results and having to go through all the training that we already have to interpret screening results, it's the equivalent of paying a doctor to do a blood draw. You need the people who know how to do it, who do it all the time because they're more efficient. And frankly, we're cheaper. We shouldn't be, but we are, right? And so, so then when analytics came through, it's, well, we'll just tell you who our best donors are, and you can skip the research team and get rid of them. And then they figured out, no, we can't.
Mhm.
So, Sarah, I'm not worried about our jobs, but you're absolutely, you're as a student as you always are. It's like, they're saying, well, can AI replace annual giving writing? No. What it can do, just like screening and analytics, is it can reduce the time spent on hand processing. And that frees up the human brain for the creative, thoughtful, meditative work. So people who like, I just go to work and I do my job and I go home, they can stay gift processors. But those of us who are in prospect research, it's elevated what we need to be responsible for because the administrative stuff, the assembly stuff is done for us. Trust but verify. Thanks, Scott.
Mhm.
How is that? How do you say that in Russian, Greg? That was Ronald Reagan's favorite
Oh,
expression.
no, I know in Arabic it's trust in God, but tie up your camel.
Yes.
Mhm. Yeah, that's a Arabic proverb. Yeah.
Okay. So Sarah's leaving. Thanks. It was good to see you.
Thanks, Sarah.
I've got to head out also, but it was great chatting with you guys today. I'll see you in May,
Thanks for coming.
All right, thanks.
of course.
Thanks, Lucy.
Bye bye.
Thank you. And thanks to everyone for attending.
Yeah, thanks for coming. I see
Mhm.
people are popping off. We're good with that.
Yep, 1 o'clock. So,
And we're also, yeah. And if you want to hang out and ask us some more questions, you've got us to yourselves. We usually charge $300
well, thanks,
for advice
Mackenzie.
hours. So
Yeah, good to see you again. And thanks for coming, Ruben. Always good to see you.
yeah, always good to see you, Ruben. Okay. And we have a few people who might be just hanging out
Yeah.
because they're reading their last email and don't know that it's over.
Yeah. Always happen.
Yep. But
And
I'm happy
we
to wait
have.
a couple minutes just to make sure in case Scott has a
Mhm.
question.
Mhm. Oh, you're welcome. You're welcome, Scott. Yes. Um, yeah,
Oh,
yeah.
yeah.
I need to. We do have our. We now have our Power BI training course up. So just if
Yeah,
you're
the course is
interested
up,
in that,
Scott.
um, and just so you know, some inside information. I'm working on a Power BI book right now. And in fact, that reminds me, I need to send Marianne my outline for that. Um, and and also an Excel cookbook. And you can imagine which one I'm head on right now.
Right,
So
right.
um, okay.
Oh, I missed him.
Oh, oh. So
Well, thanks for popping on with me and thanks for co-hosting with me.
oh yeah, yeah. I'm for some reason I know this is always on Tuesday. For some reason I thought it was on Thursday. I don't know why.
I was,
Um,
yeah, I was supposed to be at the dentist at 1, and I'm like, oh no, I have to go now.